Hi everyone, I'm Iqbal and I am here to make electrical installation in your home as easy as flipping a switch. In this series, I will break down the basics of electrical circuit, how to design them, find and fix faults, and carry out commissioning and testing. We will tackle real life problems that come up during electrical work so you are well prepared for anything. Since this is my first video, I'm keeping it short and sweet. Today we will focus on the fundamental of Ohm's law. Stick around, grab a cup of coffee or tea, and if you enjoy the video, hit the subscribe button, leave your comments and suggestion, and let's learn together. Remember, electricity isn't just shocking, it is dangerous. Always follow safe isolation procedures or hire a qualified electrician for any electrical work. Your safety is the top priority. Alright, let's dive into fundamentals of Ohm's law. Oh yeah, what's Ohm's law? The definition is Ohm's law is a fundamental principle in electrical engineering that connects voltage, current, and resistance. Equation. It states that the current is directly proportional to voltage and inversely proportional to resistance, represented by voltage equal to current time resistance. So, in simple words, um, if voltage is going to go up, if in a circuit the voltage is going to go up, current is going to go up as well, and it applies opposite in terms of the resistance. If resistance is going to go up, current is going to decrease. So if resistance is going to be double, the current is going to be half. So this is what we're trying to achieve from this equation. This law helps us understand and predict the behavior of the electrical circuits. Ohm's law is essential. There are three things we need to consider in Ohm's law. One is voltage. The voltage is the pressure which is a push that drives electric charge, and it is measured in volt. Current, the flow of electric charge. The electrons they move, they move inside the electrical circuit. They measure in amperes. We called as a current. The resistance is the opposition to flow of current. It measures in ohms. So we gotta remember three things. The voltage is the pressure, and current is flow of electrical charge. And when it comes to resistance is the opposition to the flow of the current. So that measured in ohms. So these three things we need to consider in Ohm's law. These are the basic things we're gonna be working on the next slide. The magic equation, so the formula here we got is again, as I said previously, the voltage equal to current time resistance. So if we want to get voltage, if we don't know the voltage, if we know the circuit resistance value and the current value, we can easily get the voltage value by multiplying these two. But if we know voltage and the current, we can get resistance values here by bringing R this side and dividing voltage by current. And same applies here as well. If we know the resistance value and voltage value, we can bring the current on this side, and we can divide voltage with the resistance to get the current values. Ohm's laws essentials I've already discussed, so we're gonna go to next slide. Okay, this is the real life example. In our houses, we use 60 watts, 100 watts bulb. But obviously, these days, LED lights, we using 5 watts, 3 watts as well. But I'm talking about general, the main lights, the bulb we normally use. We can call it pendant lamp. The one we use is normally 60 and 100 watts, mainly. Most of them are 60 and 40 watts. So we got here 60 watts light bulb, and the electric supply we have in a domestic property in the UK. It's a common practice. We have 230 volts electrics and domestic properties. Some of the houses they got three phases, but I'm just talking about generally we got 230 volts electric. Now in this equation, in this scenario, we got two things, 60 watts and 230 volts. But we need to get the resistance of this 60 watts bulb. So to get the resistance of this 60 watt light bulb, we need to find out the current first, because then we can uh, divide, we can divide voltage over current to get the resistance value. So to get the current, we need to understand, the power, which is, we know it's a 60 watt here. So the power equal to current time voltage. Yeah, voltage is equal to current time resistance, and the power is equal to current time voltage. So this is what we need to remember here. Power, if voltage and current, they both together equal to a power. So this is what we need to remember here. So to get a current, we need to bring current on this side as we did here. I will leave the power on top there, and we divide with the 230 watts. Yeah, we can see here we got 60 watts up there, and we can divide by 230 volts. Sorry, I said watts. Yeah, we can divide 60 watt with 230 volts to get the current value, which is 0.26 amp. Now we got the current values, we got the volt, and it's that easy now. All we need to do to find out the resistance of this valve, we need to bring R this side, and we'll keep the voltage on top and divide by the current, which is 0.26. So 230 volts divided by 0.26 amp is going to give us 884 ohms resistance value. This calculation ensures the safe and efficient operation of the light bulb. Okay, this is another example. Here we got 9 kilowatt electric shower. So we need to understand the 1 kilowatt is equal to 1000 watts. So that's why I've got 9000 watts here. So we divided power, the watts, which is we know the value of the watts, which is 9 kilowatt. So we divided 9000 watts with 230 watts to get the current value, which is 39.13 amps. Then again, to get the resistance value, it's that simple now. We need to keep R this side and keep the voltage on top and divide with the current, and we will get the resistance value of this electric shower, 5.88. That's it. Thank you very much. Oh, hi. Yeah, this is a very good example. In this scenario, we can see this water hose. The water is flowing through this hose, and we can take as a current. We can give an example. This is a current, and the power which is being used to drop this water to come out of the hose, we can say it's the voltage, and the hose itself, which is keeping this water contained inside. It doesn't flow anywhere. It's going through this pipe. It's keeping it within the pipe, contained within the pipe. We can say this is the resistance. So, yeah, this is a very good example. This is an analogy we can use to understand the difference between voltage, current, and resistance.